In the previous lessons, Sasha and Keone worked with parabolas that had their vertex at the origin. In this lesson, they see what happens when the parabola is moved to other parts of the coordinate grid and has a different vertex. The goal of this lesson is to develop equations for several different parabolas where the vertex is not at the origin. But first, Sasha and Keone use an applet to see how they can translate, or move, a parabola.
You've been working with parabolas that have a vertex at the origin. And your goal today is to find the equation of several parabolas where the vertex is not at the origin. So first we're going to explore how to move a parabola that's sitting at the origin with its vertex and move it so it's somewhere else on the grid. Now just go ahead and mess around. You can play with any of those sliders and see what happens. After you've made some observations, let me know.
Okay, H is going to move it from right to left.
K is going to move it up, down, huh?
Oh, I'm going to up down. Yeah. Ooh.
Then P is going to make it bigger or smaller.
Beep, 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 beep.
What'd you figure out?
That our P makes it wider and smaller. Our H moves it side to side. And then our K moves it up and down.
Oh, that was fast. Does changing P fit with what you had discovered last
Yes,
lesson?
it does.
And what was that?
That as our P is increasing, the parabola will be wider, and then as it decreases, it'll be skinnier.
Okay. So if you could set it back at P equals 3, H is 0, and K is 0. And I'm just going to give you a target vertex, and you have to figure out how to get it there. But I want you to leave P as 3 for a while. So for the rest of this lesson, we're going to just work with equations with P as 3. So you can leave that alone and just work with H and K. So I would like you to, I'm going to call this black parabola the base parabola. I'd like you to move it or translate it so that you get a new parabola that has its vertex at 5, 0.
Okay.
Zero.
So this will be 5, right? Because it's our A.
Yeah.
And 2, 3, 4, 5. And it was 5 what?
5, 0.
0.
Oh, 5, 0. Okay.
You got it?
Yeah.
Okay, and as you'll notice, we're going to leave the black one there just as a trace of the original, and the red parabola will be the new one. Okay, do it again, and this time I want the vertex at 10, 3.
Skills.
Skill.
Kiana, you pick one and make Sasha do it.
Hey. Okay, can't be over 10.
Negative 3 and 6.
Okay, Sasha, you give Kiana one.
6, negative 4.
Okay, so I think you guys get how this thing's moving around.
Sasha and Keone made several discoveries. If they change the value of H, the base parabola moves side to side. So if they increase the value of H to 6, the x value of the vertex of the new parabola will also be 6. Changing the value of K moves the parabola up and down. So if they decrease the value of K to negative 2, then the y value of the vertex of the new parabola will also be negative 2. Sasha and Keone also revisited what they had learned in lessons 6 and 7 about changing the value of P. Remember, P is the distance from the vertex to the focus. As Sasha put it, as our P is increasing, the parabola will be wider, and then, as it decreases, it will be skinnier. Next, Sasha and Keone figure out what happens to the focus and the directrix as they translate the base parabola.
So if you could go back to the original, to the base.
Oops.
You missed it.
There you go. Now I'd like you to move to one that we're going to work with and derive an equation for. So this one has the vertex of 7, 0.
Nope, not 8, 7. There we go.
Okay, so this is the parabola that's been moved to the right 7 units, and it's still on the x-axis. Here's the original or base parabola with a vertex of 0, 0, and then your new one, the red one, has been translated or moved to the right 7 units. What's the focus and directrix of the new parabola? You can label them in red if you want to fit with the red parabola. Sasha, what do you think of that?
I agree because all we did was just move it over 7, so it makes sense for the point to be at 7, 3.
Okay. What about the directrix?
Okay, I'm going to assume
It's the same, right?
Still.
It's an
3.
ugly line.
So why do you think the focus changes but not the directrix?
Because we were moving, I don't know.
Because like the focus is a single point, so it needs to be kind of specific, but then the directrix kind of covers a large scale of it,
Okay.
so it can work for more than one focus.
Okay. Can you see the p-value for this new parabola?
3.
3.
Can you label it for me?
You want to circle?
Circle.
Or just like line up?
Like p equals 3.
And where else is it? Okay.
Sasha and Keone figured out something important. If they start with a base parabola that has its vertex at 0, 0, and then move the parabola 7 units to the right, the distance between the vertex and the focus stays the same. This means that the y value of the focus for both parabolas is 3. Only the x value of the focus of the new parabola changes. It will be 7 instead of 0 because the focus was shifted to the right 7 units. Sasha and Keone also figured out that the directrix is the same for both parabolas. That is because the directrix is 3 units from the vertex of both parabolas. In the next episode, Sasha and Keone develop an equation for the translated parabola.